Today I am going to discuss a role of amino group on benzene ring. In this lesson we are going to learn resonance structures of aminobenzene and then reaction mechanism of aminobenzene. So let's get started. Resonance structures of aminobenzene. Let's see. Double bond, here double bond. Nitrogen contains one pair of electrons. Here there are two moieties. One is amino group, another one is phenyl group. Here phenyl group is initiator of resonance structures in this way. That is, inside benzene ring, pi bonded electrons move continuously. Because of this continuous movement, phenyl group achieves electron withdrawing nature. This is number one. Number two, all the carbon atoms of benzene ring are sp2 hybridized. We know sp hybridized carbon is more electronegative than sp2 and after that sp3. So sp2 hybridized carbon is electronegative carbon. That is why phenyl group achieves electron withdrawing nature. As a result, lone pair electrons of nitrogen turns into bond pair electrons, and as a result here electron-electron repulsion is created. Because of the electron-electron repulsion, these pi bonding electrons turn into lone pair of electrons and we get this resonance structure. Double bond NH2. Here lone pair of electrons turn into bond pair. That is why double bond. At the same time, nitrogen gets positively charged. Here bond pair of electrons turn into lone pair electrons. This is double bond, this is double bond. That is, here ortho carbon gets electronically rich. Ortho carbon becomes negative in charge. Again, this lone pair of electrons turn into bond pair and this bond pair of electrons turn into lone pair, and this is found. Positive charge. Here double bond is formed. Para carbon becomes electronically rich. Here double bond. Here ortho carbon gets negatively charged. Here para carbon gets negatively charged. Again, this lone pair of electrons turn into bond pair and this bond pair of electrons turn into lone pair, and this is obtained. Double bond nitrogen hydrogen positive charge. Here double bond, here double bond. Again ortho carbon gets negatively charged. Again this lone pair of electrons turn into bond pair and this bond pair of electrons turn into lone pair again, and now this is obtained. Here carbon nitrogen double bond turns into carbon nitrogen single bond again, and here double bond, here double bond, here lone pair of electrons. Again this lone pair of electrons turn into bond pair, this bond pair of electrons turn into lone pair. That is, now this is obtained, and then this, and then this one. That is, through the formation of resonance structures, orthocarbon becomes negatively charged, then paracarbon becomes negatively charged, and again orthocarbon gets negatively charged. Resonance hybrid structure is this. Over nitrogen, partial positive charge, here partial double bond, inside benzene ring partial double bond, orthocarbon partially negative in charge, paracarbon partially negative in charge, again orthocarbon partially negative in charge. That is, amino group increases electron density in benzene ring. As a result, ortho and paracarbon get electronically rich. That is, amino group is benzene ring activating group towards electrophile through positive mesomeric effect. Positive mesomeric effect. Mesomeric effect that involves lone pair of electrons and pi bonding electrons, but inductive effect involves sigma bonding electrons. So here amino group increases electron density in the benzene ring through positive mesomeric effect. Amino group increases electron density at ortho positions and at para position. Then electrophile can attack orthocarbon and paracarbon. So amino group is a kind of ortho-para directing group, and it's a kind of benzene ring activating group towards electrophile. Let's summarize the discussion. That is, amino group, ortho and para directing group, and this is benzene ring activating group. This is all about resonance structures of aminobenzene. Let's move on to the next point. Now, reaction mechanism of aniline. Let's see. Aniline or aminobenzene. We learned that amino group is a kind of benzene ring activating group, or this is ortho-para directing group towards electrophile. So because of the presence of amino group, electrophile will attack orthocarbons and paracarbon in this way. Here electrophile and hydrogen, and inside benzene ring there is created positive charge. Now this is called sigma complex. Because of the presence of positive charge, covalently bonded electrons of carbon-hydrogen bond move towards benzene ring, and after that this hydrogen gets freed as electrophile, and this is obtained. That is, electrophilic substitution occurs. So aminobenzene undergoes electrophilic substitution at ortho position and similarly at para position. When electron donating capacity of amino group is increased, then at a time electrophile will attack orthocarbon, paracarbon, and again this orthocarbon. That means 2,4,6 tri-substituted aminobenzene is produced. When electron donating capacity of amino group is increased somehow, That is, from aminobenzene we can get three kinds of products: ortho-substituted aminobenzene, para-substituted aminobenzene, and at a time ortho-para-substituted aminobenzene if electron donating capacity of amino group is increased. This is all about role of amino group on benzene ring. No more today. Thank you very much.